It's time. So thank you very much to Johannes Bergberger. He will be speaking about Python 3.12 new monitoring and debugging API. For those who were in the previous talk, there was a brief about the profiling features. Johannes is a JVM developer working on profilers at SAP. He also writes blogs about profiling and debugging topics. Thank you very much.
Thank you for introducing me. Before we start, I want to introduce you to the concept of debugging, because I'm sure nobody of you have ever debugged. So the first bug that was found was in the 50s when they found a moth that was in between their relays, and it makes zip, and the whole system crashed, because in the olden days you had relays. At Skadaiska once wrote, if debugging is the process of removing software bugs, then programming must be the process of putting them in. As I'm sure all of you are doing lots of programming, I'm sure you're also doing lots of debugging. So that's why we're here. So consider this example program. It's called a counter program, which just counts the lines in this example in itself, and it returns 0. And we're like, why? So that's a problem, because the file actually has 26 lines. So let's look at the code. If we glance at the code, make this shortly so you don't see what it's about. But the idea is we use a debugger through this, because debuggers are great to understand our system. And the cool thing is now with the new APIs that we get in Python 3.12, writing debuggers is far easier and far faster, as I show you in the following. I'm Johannes Bergberger, as you already heard. I work at Submachine, which is the third biggest contributor to the OpenJDK, which is the major Java runtime. And I started talking to people about Python because I also like Python, and it's a bit easier to VM than JVM. The question is now, why do we need a monitoring and debugging API? Because I'm from the Java world, and in Java we haven't built in debugging API. So we have the ability to set breakpoints, to ask for values, to walk the stack and have everything. But in Python, does the Python interpreter know about the concept of breakpoints? So because I'm here, not only, but with you here, who of you thinks that the Python interpreter knows about the concept of breakpoints? Please raise your hand. And two of you thinks it doesn't know about the concept of breakpoints. Okay. It's a trick question. Of course, no, because otherwise it wouldn't be asking this question. So it doesn't know anything about breakpoints, which is not a bad thing. So any ideas how we could implement it? So the first idea that came to my mind was we have this code. This is actually the code that was part of the CounterPy. So the idea was we just place in front of every line a debugging statement, like a debug method that we define somewhere. The idea is simply put, in this debug method we check, are we currently at a breakpoint in this file and line? And if yes, we open some kind of debugging shell. If you've ever used PDB before, that's essentially so it's the PDB shell that we could be opening. But the question is, how we get this file and line? And the easy answer is we have this getFrame method. It has an underscore, and the important thing is that it has an underscore because it's kind of a CPython implementation detail, which is great, because it's pretty slow in PyPy. So yeah, but we have to live with it, because that's the only way we can walk the stack. We've seen before that we can do some eBPF stuff, which is nice, but usually most profiles, not most debuggers don't do it. So the idea is here we have our stack, on the bottom is the main, and then count lines is code line, and then our debug method. And essentially what we do, we can ask getFrame, the 0 frame, that's the top frame, because we're currently in the debugging method, and so we ask it for the frame 1. And also get it from the other frames, and essentially what we can get is information on which are the local variables, which is the file name, which is the line number, and such. And that's quite nice, because this allows us to easily implement the debugging shell, because we can just open the shell that contains these locals. And so that's how we implement our first debugging method. And it's nice and it works. And we can even write some basic debuggers with it. The problem is we want to automate this because we don't want to put this dbg statement in front of everything. So how do we do this? And first I'm going to tell you about the pre-3.12 way so you know the pain points of debugger developers here. The pre-3.12 way was the way of this.setTrace, which was an arcane way to do it, but the idea is essentially we pass it a handler and this handler is called multiple times. Essentially, this handler gets parsed the frame type, the frame, and an event type, which could be like call line, return, or exceptional opcode, and it would be called regular time. So when we then register it, we register a specific handler, and this handler then is called at every call. So every time the method count lines in call, it's called, and every time then also a method is code line that is used here is called. And that's nice, but we want to know more. We want to know also, we want to get a handler on every line. So what we do, we can return from this handler an inner handler that's called for every line, and this has the same signature. So the idea is we essentially implement our debugger here by not using like our writing it manually here with the dbg, but just setting an inner handler. And this is called at every line. And that's quite nice because it works, but you might expect, I'll show you later, it's quite slow. But it's okay. We can even go to the opcode level, to the bytecode level in the here. But the problem is, and the question here is, do we need a line event for every function? Because we know when we set a breakpoint somewhere, we only need to like set a breakpoint, we only need to like check the lines there. But for example, consider that we have here this count lines, and our user decides that he adds a breakpoint when we in is code line. So there's a breakpoint also in is code line, and he in is code line decides, hey, I want to add a breakpoint into count lines. The problem is when we haven't passed like inner handler to the method here for count lines, we can't enable line tracing for count lines. So we have to enable it for every line of our whole application, which is kind of a mess. So this is slow. So there are multiple ideas how to improve this, and one of the best ideas, and if you're a Python developer, you should do this, if you're a Python core developer, is to add a new API. And this API is called Python, and this API is defined in the PEP 669, and it's really, really cool. And the cool thing is also that this PEP is written in a style that you can easily digest. I come from the Java world. This is not always the case with the Java PEP, so with the JEP, so I'm quite happy that Python does things a little bit better. So the JEP is called Low Impact Monitoring for CPython, and hopefully other runtimes will support it in the future. And it's here since October. So the idea here is that we have more fine-grained support, that we learn from the lessons that like having to enable the line handlers for every line is probably not the best thing. So typically when we develop, when we use this PEP, we define some shortcuts here in the top. So we don't want to write sys.monitoring all the time because that's where the monitoring functions live. So we call it mon, and the events, it's also a bit long, so we call it mon, not events. And then we have to assign it the tool ID. So the idea is that you can have multiple tools that are registered here. And for each tool, we register some callbacks. So what we do here in our example, we register a callback for our tool. Our tool is a debugger. There are like 6 possible tool IDs. One of them is a debugger, another one is a profiler. And we register here a callback for the line because we want to still have like line callbacks sometimes. And we also register a callback for the start function. So for the start event, so when a method is called. Then we have these handlers, and the start handler is just passed like the code object. That's what you get when you for function called f underscore code, and the offset where this is located in a bytecode, and for line handler we get the line where it's in. And the cool thing is here we can return from this, as you see in the bottom, the line handler also can return either disable or any. And the cool thing is when we disable, it's disabled all the time for this specific line, and it's called for coverage. So we can also make coverage testing easier. So yes, we enable then the start events, and that's fine. And then we run our program, we get a start event for every function that we call, and then at every time we ask, hey, do we have a breakpoint in this function? If yes, we enable the line here, but only specifically for this function. And then for every line we check it. The cool thing is that these line events are emitted per thread. So the idea is that with sys.ztrace it was emitted like in the main thread per interpreter, but here it's emitted for every line in the thread that the handler is that the function is currently executing, and this is really cool. And Lukas Langer wrote in a PR discussion, the biggest opportunity of PEP 6.9 isn't even the speed, it's the fact that the debugger built on top of it will automatically support all threads and supports threads properly. And with the incoming changes with PEP 7.03, with making the global interpreter lock optional in CPython, it will get far more important, because with then we will probably see multi-threading Python applications, and then the old approach is just not usable anymore. So the idea is that we can enable events globally and locally, and the sum of both is like the enabled events per function. And the cool thing here is the power is in the fine-grained configuration, so you can set events in a function f for the function f while this function is running. So consider this example here. We have a simple line handler here, and you register a callback for each line. And then in f you decide at some point, hey, I want to set the local events. I want to enable line events. And later you disable them. And it works. So here we emit hello, and then we emit like, hey, we're at line 18, which is like the line that prints inner, then we print inner, and so on. And that's really cool. That wasn't possible before, and that's really great, because this enables us to only enable line events for the functions that we will need them. And so the question is, of course, what's fast? There are several methods and in this PEP, in this API, and what's really fast is to register callbacks. So we can easily switch out the callbacks and get the tool. So we can say, please get the tool ID. What's kind of fast is setting local events, because what it does, it modifies the bytecode that the VM is executing, and what's pretty slow is to use a tool ID to like start the debugger here, and to set the global events, because this potentially recompiles or modifies all bytecode of every function. So do it early, so then it's fine. So back to the debugger. We had here our start handler and our line handler, and they look essentially the same as before. The only difference is that we enable the line breakpoints whenever needed. So they're different than events kinds, because we've seen that line events are pretty powerful for implementing basic debuggers. One of them, we've seen already the start events. There's the resume, return, yield events for everything that you do in like your Python application. And there are also then ancillary events. These are events that aren't like that you can't enable or disable, because they come from they are controlled by other events. So for example, you have the call event that is triggered whenever you call a function, and then we have C-related, a C-raise whenever exception is thrown in C code, or whenever a C function returns. And there are, of course, then also other events that are not enabled locally, but only globally. Essentially, the idea is we cannot locate them properly. And the cool thing here is, maybe you've seen that we have a new event called stop iteration, because with, I think it was in this Python version, we're not using in iterators when we're returning from iterator. Previously we wrote an exception, but that's pretty slow, so we don't throw an exception anymore, but to debuggers to still notice it, we have a new stop iteration event. Of course, what we all be waiting for is performance, because the performance is like the thing that, besides the threading support, is pretty neat. So what I did, I looked around and I found some people also doing some performance tests, but they were using Fibonacci functions. And I'm like, that's a bit small, that's not representative, so I started looking into Python benchmarking suites, and there's this PyPerformance benchmarking suite. And I just hacked it. I just wrote random code in it, because you can do some kind of monkey patching in Python, and it's great. And in Java, we have like private functions and everything. In Python, you don't have to care, and that's why I like using Python. You can do things that you're not supposed to do to get some great results. So if you wonder, I'm using Python all the time when fixing bugs in the OpenJDK to write test suites. So because it's far faster in Python than to do in Java. So you guess the OpenJDK, some bugs were fixed because I wrote some weird Python script here. But essentially what I was then going to test is I wanted to check the minimal implementation of a debugger. So minimal implementation with this set trace, so a debugger that doesn't have any breakpoints here, is just a call handler, and then an inner handler calls at every line. Then the minimal implementation for a monitoring API wouldn't set any line events, because wouldn't enable any line events, because when we don't set a breakpoint, we don't need to set any line events. So that's how we implement this. But I thought, like, yeah, it's a bit sneaky, because we're comparing something that triggers an event at every line with something that only triggers an event every function call. So I also made a third comparison with like setting all the line events. And it turns out that's still faster, which is quite nice. So I use this Python benchmarking suite. That's quite representable. And what I found is that it's really, really fast. So that's the sysset trace, when you run it, when you run all the Python benchmarks with sysset trace on, you have a 3.5 times larger runtime. That's very slow. When you're using monitoring, you only have a runtime increase of like a factor of 1.2, which is like 20% slower, which is pretty awesome. Because this means you can debug all your tight loops, you can debug your whole applications without worrying about like debugging slowing down. And when you enable all line events, it's still 30% faster than with sys.settrace. And people here probably like Rust. That's essentially all the benchmarks that are in PyPerformance. And what you see here, the orange bars, these are the bars for the monitoring solutions. And here it's just at 1. So if the bar is not visible, it means you don't have any overhead in this benchmark. But essentially, you see that the blue bars for set trace can get high, can get up to like 10, 12. So it's really good, and at least in my opinion. And then when we switch over and use sys monitoring with all line events enabled, it gets worse, but still we see that it's still significantly faster. And now the question is, of course, is this whole thing used? Because it's implemented, and I'm working on JK, so I know that when you implement a cool feature, the chances are that nobody will use it for like a year. But here in the OpenJK, people started, but here in CPython, people started using it, especially the vendors like PyCharm. So it's not yet used in PDB, and I'll show in a second why, but IDEs like PyCharm with their version 2023.3 use it, and they've seen significant performance improvements. And there's currently a pending pull request on GitHub, so if you want to help PDB implement it, go to this pull request and join a discussion here. So I would really recommend. It's an open source project, CPython, and you can make PDB better. So what not to like? What not to like is simple. I Here is a quote from the pull request from Chen Gao, who wrote this pull request, and he wrote, after this change, we will have the chance to build a much faster debugger. For breakpoints, we don't need to trigger trace functions all the time and checking for a line number. So I've showed you. The bad news is it's almost impossible to do a completely backward compatible transition because the mechanism is quite different. So there's an ongoing discussion how to do this. You could take part there, so scan this QR code, be part of the community, give something back, and not just use cPowerShell. Because I have like tiny time left, I want to just show you shortly how single stepping works, because single stepping is just breakpoints. Because essentially the idea is here, when we have our stack here with the isColon or tab, step out is pretty simple. We just check for the next line where only the frame before changed, like the current code lines changed. Stepping is also pretty simple. We just check that only like the line number changed. It's also nice. And then step into is we check the next time where we just put the frame on top. So that's all from me. I'm Paradigm.Node on Twitter. You can find my team at Submachine.io. So if you want to use a JVM, use the Submachine. It's the best JVM. I'm contractually obliged to say this now. We work at one of the. We're at SAP. We're one of the many cool open source projects at SAP. You can follow me on my blog where I regularly write on debugging, eBPF stuff, and everything else. So thank you for being here.
Thank you very much, Johannes. We have time for probably 2-3 questions, maybe. Does anyone? We have one there.
Thank you very much for this talk and for this PEP, because it actually solves a lot of problems I had when I started back in the days developing a tool for performance analysis for Python. However, I at some point choose to use the C interface of set trace and profiling and whatever. Does your proposal, as you said, it's implemented already, also support the C interface?
So I have to correct. I have nothing to do with the nice people who implemented this. Sorry, but so please ask them. They're probably in some Discord somewhere. I'm just telling you about the good news because programmers usually don't want to go to conferences and speak in front of people. So that's why I'll be giving talks on this. So sadly, I don't know.
Thank you. Do we have any more questions to Johannes? You can raise your hand. No questions, apparently. I just wanted to use this opportunity to thank Marc-André and David, also known as FlyPig, for organizing this dev room. You guys did an amazing work. Thank you very, very much. And thanks to Johannes again.